Hello, and welcome to the EMC Live Roundtable, Elephants in the Test Room, Part 2. My name is Belinda Stashikevich, and I'm editor of Interference Technology, the creator of EMC Live. EMC Live is an online 3-day event hosted by Interference Technology. Featuring practical information and topics, this event will include roundtables, webinars, and videos on everything EMC related, and there's no cost to attend. Join us for our other webinars and roundtables this week. This roundtable is moderated by Tom Mullineaux. Panelists include Patrick Andre of Andre Consulting, Steve Koster of Washington Labs, Joe DVAC from Amplifier Research, and Bruce Fagley from TUV Rhineland. As an author and RF engineer, Tom's been in the EMC industry for 20 years, both as a supplier to the industry and as a hands-on program manager, achieving EMC compliance for new products. This roundtable is one of many this week. To check out our others, visit emclive2015.com. A recording of this webinar will be available on our website. This roundtable will be interactive. You'll be able to ask questions, and we encourage you to participate. Take a look at your GoToWebinar navigation pane, the box on the right-hand corner of your screen. If at any time you have a question, we ask you to fill out the type box and hit send. To make the screen minimize and maximize, click the arrow button. To raise your hand to ask a question or to report an issue, click the hand icon. We'll discuss the topic for 35 minutes, followed by a 10-minute question and answer session. Now Tom will kick off the roundtable.
Thank you, Belinda, and welcome everyone. For those in the audience new to Elephants in the Test Room, as implied in the name, these are EMC test controversies that everyone seems to know about, yet few, if any, openly discuss. The elephants usually prefer to reside in the test chamber at EMC test houses, and often their presence is just awkward, at other times downright scandalous. Our first elephant today actually resides outdoors in the form of an open area test site, or OATS. It goes under the title, Addressing Poor EMC Measurement Consistency. There is a certain amount of irony in the fact that an EMC test facility is denied accreditation if the facility does not offer OATS testing. Yet it was confirmed during the last EMC Live event that there is an enormous disparity in inter-site OATS measurements. This begs the question as to why such a reverence is given to the OATS test site and why they are used as the basis of any type of reference at all. Can the ISO 17025 department charged with covering EMC laboratories not work with the EMC industry to improve OATS measurement consistency? Now let me start with the detraction. As was pointed out by every single member of the panel, actually you don't need the OATS to have accreditation. If you can prove that you can reach a certain standard on any particular test, you'll be accredited for that particular test. But I would put it to you that OATS still has a lot to answer for. It still seems to be the golden reference. It's had an impact on the industry from early days. The reason there are high ceilings in 3-meter chambers to cater for the 4-meter height, born in the OATS setup, just so they can claim equivalence. The fully reflecting floor and the issues that cause is again born of the OATS setup. And test locations way out in the boonies and miles away from transport hubs or airports are there because they're seeking low ambient noise. I put it to you guys that OATS still has a lot to answer for, although I do detract the case that you need them for accreditation. Joe, what's your view on this?
Well, Tom, my position is that the OATS are still of value in certain situations. One of the main things I believe that can help with consistency across the OATS is with the adoption of the 17025 as a backbone to the lab quality management systems. ISO 17025 has allowed labs to perform and encourages and mandates them to perform interlab testing. These tests are performed with a known radiator, so labs can, check from each lab the radiated emissions and profile those at specific frequencies, and oftentimes that helps them mitigate any issues they may have amongst each other. 17025 also, in addition to the interlab testing, also provides and encourages and mandates, of course, personnel training on a regular basis. So that's just not on the test procedures itself, but should be extended to lab and site maintenance. So maintenance could include things like checking the ground plane for any damage during off-season, such as winter periods. Checking the masts and turntable to make sure they're performing properly. And checking for cabling and so forth, connections. So all these things help to manage the uncertainties that can occur throughout time with a lab. And again, ISO 17025 is more of a life cycle type procedure and process, so that you're always looking for process improvements to improve that lab site as much as possible. Now, of course, it cannot help with any ambience that you may have with the site. That's a different area altogether. But with the conditions under your control, it can certainly help with consistency across lab to lab.
So basically you're saying because of the overarching ISO 17025 quality system, everything should be fine. Well, I'd like to thank the audience for listening in, and have a great summer, and maybe tune in next fall for the next EMC Live. But I don't think so, Steve. Does the overarching ISO 17025 actually take away all the disparities that presently exist?
Well, ISO 17025 does account for that. However, the auditors and accreditors don't seem to put a large push on that. For example, as running a test lab, if you go out on the internet and try to find a performance test, there's only one that I know of that's accredited. ACIL, the American Council of Independent Laboratories, has an accredited PT program or performance test for radiated emissions and conducted emissions. But aside from that, there aren't any out there that you can find that are like a third-party performance tests. Now, if they were pushing harder, I would suspect, or I would speculate, that there would be more of them available, or the accrediting bodies themselves could come up with their own performance tests. You know, because the one from ACIL, we participated in it and found that especially down at 30 megahertz, the labs, there was 10 labs that did this performance test, and they were off by as much as 30 dB. It went from minus 15 to plus 15. So there's a large disparity there. But if you were using it for your interlaboratory comparison for ISO 17025, you would obviously have to go in, understand the issue, do the root cause analysis and all of those types of things in order to correct it. So the reason I feel that there isn't as much of a push on that is because, again, there's not that many, there aren't any out there that are interlab comparisons, because why would you as a test lab call your competitor and say, hey, you want to do interlab comparisons with us, I'll send you a piece of equipment or whatever. So it gets to be a little more difficult, especially as a private test lab.
Good point. Good point. Why would you aid a competitor, or why would you want to work close with a competitor? It may not be good for you. Bruce, why is there such a disparity? Is the staff all stupid? Is it because it's going to rain? Is it because there's a herd of cows walking past in the next field? Why are these things? Why are they so very different? What's so hard about it? Bruce,
coming from a test lab program,
you need to speak up a little, Bruce. Speak up just a little.
Okay, sorry. Coming from a test lab background, I can certainly agree with Steve's comments there. I think a lot of the measurement consistency issues that come into play now are the realization that there are many different factors that come into the measurement consistency issue. You know, the site has is part of the problem there, but we're all using different antennas. So when you're comparing 10 different laboratories, there's several different antennas and lists of equipment that are different. So there's a lot of factors that enter into the measurement consistency issue, and I think that all of this makes it very difficult from an accreditation standpoint for an accreditor to deal with this issue when you have such disparities in the readings from the ACIL program. So obviously we need to come to much less variations in the consistency before the accreditors can actually begin requiring this, I would think.
Makes me feel despondent to hear that, because how you don't wish to dictate to people, okay, thou shalt use this antenna and this particular brand and no other. That's anti-competitive, and on the face of it, shouldn't be necessary. Look at what we have. We have a large sheet of metal on top of which are two non-obtrusive mass, on top of which are two antennas, proving that this is within normalized against perfect conditions. It doesn't stand to reason. Now, I can give a little bit of input here. I visited ETS Lingering the other day for a chapter meeting, and we were given the tour, of course, and they've got this colossal outside. It's like 80 meters by 50 meters. It is colossal. And even be over and beyond the metal plate, they have, like, I'm going to say, hawsers of non-rusting steel or something going out, spreading out outwards everywhere around it. But the main purpose they've got such a large facility is they use theirs for antenna calibration, where they have to be plus or minus 2 dB, as opposed to the normal oat sites of plus or minus 4 dB. It just why does it have to be so much bigger to get an extra 2 dB? I just wonder. I wonder about the wisdom of using them for any reference at all. What industry in the world wants a random reference? It makes no sense. But Pat, I mean, I was asking around, and it seems we're getting fewer and fewer oats test sites. You know, you've got companies that have, say, 5 or 6 test labs or more, and they maybe have 1 or no oats test sites. Are we seeing the demise of the test site, of oats test sites? Are they slowly going away, which might be a good thing? What's your view on the future of the oats test site?
Well, yeah, I think they are ultimately going to go away, and thankfully so, as far as I'm concerned. However, oats test sites are still what we consider the golden standard, kind of like tuned dipoles. Going back to what Bruce is saying about the various types of antennas, ultimately we can go back to a tuned dipole and take that variable out, the antenna variable out. Not anyone's going to do that because it takes forever to do a test with tuned dipoles, but at least we do still have a golden standard. We also have to deal with the fact that we have a lot of heritage equipment out there that was tested on open area test sites. If we start removing the open area test site and going to chambers or something like that, we may have a discrepancy between what's out there and what was originally tested.
I don't understand, Pat. What do you mean by legacy equipment out there? You mean it's 20 years old and originally it was calibrated with using oats?
Well, equipment that was originally tested on an oats, and now we're going to be double checking it by testing it in a chamber. Are the results going to be the same? They should be. However, they may not be. And now, which one's right? You know, and there lies in a big question. Ultimately, I would love to see this whole idea of reflective ground planes and scan height antennas go completely away and go with the concept of what we call a fully anechoic chamber, or a FAR,
gets my vote. I'm an RF engineer, and the first time I walked in one of these chambers, I wondered what the heck was going off and how you could ever get measurement consistency. And this chamber, of course, is trying to replicate oats. But sorry to interrupt. Go ahead.
Yeah, that's exactly right. I mean, now we've got something that I think we have more repeatability. However, now we have to change the limit lines. So which limit lines are right? Because in a FAR, you don't have a reflection, and you don't have maybe a 6 dB increase because of that reflection. If we tuned everything exactly right, the antenna height is just so. And now
you mean they deliberately introduced second path for the RF wave by bouncing off that reflected plane?
Yeah, which can add up to a 6 dB increase in the emission with that tuned or with that in-phase reflection. That's gone in a FAR. So do we change the limit lines? If we change the limit lines, I'm sure that we would have a huge uproar. So it's not an easy answer. We're going to end up with probably having to deal with oats and probably have to put them on the moon so we can get good ambience and any sort of repeatability. But it's not an ideal world, and I'm, for one, scratching my head what to do next.
Yeah. So let me tell you what I'm doing here, panel.
Guys, I just want to jump in, let you know there's about 10 minutes left of this topic.
Thank you.
Yep.
Okay, guys, I want to jump in here. My thinking, what's behind my thinking is, why aren't all these bodies that do the accreditation, that visit these labs, why aren't they all working together? What are the hurdles? You know, is it because they compete, like sort of previously mentioned? But this is competing for business of providing an accreditation service. And to try and pull those hurdles out, you know, why aren't these guys volunteering? Let me pose this question. If you were a board member charged with the well-being of a company and its financial stewardship and all those wonderful things, the reason you're on that board, and your company just happens to be one of these ISO 17025 audit companies, what would you need to know before voting company resources committed to interlab measurement improvement project? What would you need to know before you would put your hand up and vote at that board meeting, yes, let's spend $20,000 on this? Now here's a real question. Are you opening a can of worms? Is that why these guys are so quiet? What's the hurdle here? What's the big hurdle? Why isn't not one of them stepping forward and saying, okay, I'm going to run with this? So guys, if you were one of these board members charged with the well-being of a company, would you open that can of worms? Steve, what would you do?
Well, as a board member,
what would you need to know? That was the question.
Yeah. As a board member, I'd first have to understand more about what we were doing. How are we going to consider what is inner site consistency? Is it 4 dB? Is it 6 dB? Is it 1 dB? And then after that, I've got to figure out how am I going to get a performance test that's going to be able to hold the consistency that we want. And then ultimately, if we're doing it and the other audit companies are not, is that going to drive my customers to them because they're not quite as stringent? All of these things would have to be taken into consideration, I believe.
Yeah. You see, on the face of it, let's step outside the boardroom for the moment. And let's just be a third-level manager, and we put this forward and it gets presented to the board, and we would say something like, we're already auditing 20 laboratories in our own rights. We're in a competitive situation. We'd like to be auditing 40, but we're auditing 20 because other competing companies win the business. But within that narrow 20 companies that we're pretty much keepers of the data, is there truly nothing comparatively low cost that we could be doing, if only gathering the data, to look at improving intersite consistency? See, on the face of it, it sounds easy to me, but of course I'm not a board member, and so what does the rest of the panel think? What is wrong with what I just said? That on the face of it, these guys have the data from 20 laboratories, and we're talking the specific narrow field of Oates test site. We're not bringing in all the different tests and all the uncertainties and so forth with those. This is the one elephant that lives on the Oates test site. Why couldn't we do that? Why couldn't we do that? If we were 4 or 5 accreditors all working with the same company and we had these 20 lots of data purely on Oates test sites, what would stop us from going forward? Of course, we'd need board approval, but what would stop us from going forward? What do you think? Is it too hard? Because I sometimes get a little exasperated as to why is this so difficult to fix.
This is Bruce. I just had a comment on that. I think that part of the problem here is that the ACIL study or some of the studies that we've done so far have proven that there's a big discrepancy, especially down at 30 megahertz. So how can you proceed with an accreditation scheme when you have 30 dB of discrepancy between labs? There's got to be work done to get this to the point where we are much more consistent between labs before the accreditors can start working on this, I think.
See, it would never happen. I just love this panel here to be given the funds and the means of. I mean, I'd go visit each one and have a look and look for differences. Look for what the differences are, and I don't think it can just be antennas and so forth. I think it's something more fundamental. I mean, why is it that you can get plus or minus 2 dB when you use one for antenna calibration? Okay, it's cost you a fortune because it's a colossal thing, but by making the ground plane larger, what are you actually doing? Are you giving somewhere for fields to terminate? I'm kind of suspicious there might be edge effects that no one talks about. And if I'm right, it's a case that the edges of this gigantic plate is being moved further away from the antennas. And in fact, I was at the Santa Clara EMC symposium, and I sat in on a young man, and he was talking about applying edge absorber to a PCB and how that made it a far better behaved system RF-wise. It really killed, and he was talking about effervescent fields and so forth. I don't believe there would be effervescent fields from this giant plate, but I wonder if you, especially at the lower frequencies, if you don't see some sort of currents induced in this giant thing, this giant plate.
Hi, Tom. Just one. Sorry to interrupt. Just about 3-4 minutes left on this topic.
Thank you. Mm-hmm. Thank you. So,
okay, this is Patrick. The one thing that I have noticed in the past, I worked at a testing laboratory, and we had 3 open area test sites, all located in the same place, all with the same dimensions, all constructed the same. And there were 6 to 8 dB differences in some frequencies between them. But one was over a different type, even though there was a ground plane. One had wetter ground underneath the ground plane and was closer to a line of trees, even though it was outside the oval. And the other one was more in the open. The ground was a little bit better drained. And so we started seeing these differences. And it's like, good heavens, there's so many variables. And why? I mean, no wonder it's plus or minus 4 dB on these open area test sites. And even then, it's a struggle to get plus or minus 4 dB. I'm just glad that my speedometer doesn't need to be plus or minus 4 dB because, I'm sorry, I was going 60 or 4 dB. This has got to be one of the most inexact sciences we deal with.
Yeah, let's try and be fair here. Now, if the people who stand behind the Oates test system were to say to me, we believe this is a Gordon reference from 100 megahertz upwards, I would agree with them. It's when you start getting down to 30 megahertz and you get such a badly behaved system such that the needles and counters are waving everywhere just because a herd of cows is walking by. I mean, that's a really bad system. I don't think anyone has ever actually got to the bottom as to what is happening at 30 megahertz with these things. And where I was going with when I stumbled across this young man giving his paper on edge absorber on a PCB, and how that quietened not only the noise but made it a completely better behaved system. I'm about to get permanent access once the contract's signed. I can't do it for profit, and I don't get any commission or anything like that. But as long as I only use it for education, I have access to the full suites of CST's 3D EM software. And I, at the stroke of a key, can change variables on a mock OATS test setup. And I wonder if maybe, I mean, people don't do that. They tend to use the 3D for commercial products and doing cell phones and the likes. But of course, you can scale, and there's no reason the 3D software couldn't simulate first model and then simulate an OATS setup, and we'll maybe change some variables. One, of course, would be to change the ground plane to 80 meters by 50 meters and see, do you really get plus or minus 2, so forth. But I'm still suspicious about edge effects. I could be wrong, and would be happy to be so. It could just be that the larger ground plane is allowing field to terminate better. But I'm a bit perplexed from what you said, Bruce, when you said that it seems to be sensitive to the substrate that the ground sheet is on, because I was of the belief that the whole idea of this giant ground plane, a quarter of an inch thick and God knows how many meters by how many meters, was to pretty much make it independent of the substrate. And I don't know, but I guess that in early days when OATS first started, they relied on, they got atrocious measurement consistency because it depended on the substrate. If you just used the regular tarmac, cadmium, asphalt or whatever, you just happened to build the OATS test site on. So I think that brings us, I think you can hear the exasperation in my voice. I wonder if this will ever go forward, or whether we're going to see the end of the OATS test site, which pretty much would make this entire thing moot. But what I shall be doing, and if you follow the Elephants in the Test Room blog sites, I'll publish it there when I start, once I got the license, and I'll start, and I'll keep the audience in the loop as to where that particular exercise is going. So talking of calibrations and so forth, the title of our second elephant for today is the search for a golden emissions test setup proving emitter for use in 3-meter chamber tests. And the abstract reads, the use of a comb generator's output signature is a good method for checking all is well with an emissions test setup, but in reality simply proves the test system is consistent in providing the same wrong readings as before. Spot test frequencies from signal generators overcome arbitrary power levels and frequencies produced by comb generators. Is there a way to utilize existing calibrated test equipment and signal generator spot frequencies to calibrate the 3-meter chamber emissions test setup? So let me pose a question and kick things off here. Let's say your test staff, diligent as they are, accidentally fall backwards and squish some of the pyramidal absorbers on a wall. They're embarrassed and they manage to straighten them out best they can, and the damage was barely noticeable. How would you know? How would you know that? So Bruce, what do you think of the basic premise that we should have, rather than just a comb generator and making sure the signature on the analyzer screen is the same as it was last week? Is there a better way? Is there a better way, given we have calibrated spot frequencies, we have amplifier powertrains that can boost that to a decent level instead of being lost in the noise floor? We can actually give it specific, probably logarithmically spaced spot frequencies and check that the chamber's doing as it should do. So Bruce, any comments on what's my contention that if the chamber was damaged in some way, that the comb generator wouldn't pick it up?
Well, Tom, I can tell you that accredited labs all have to do periodic performance checks of the chamber, and as you say, most of them do that with a a comb generator. We do the same, and we would do a before use check of all our chambers before they're used for any testing. So it's a very common way to do it, I think. And honestly, I think in that situation, if cones were damaged or there was some deviation, I think you would pick that up using a comb generator. I think that we have also seen that the use of a comb generator to check the chamber up at very high frequencies, up to 40 gigahertz, the setup is very sensitive to physical layout and position and everything. So it is challenging to get consistency there, but as an accredited lab, I think that's a very common way to check the performance of the chamber, and it appears to be working well, I think.
So, Steve, do you concur? Do you agree with Bruce that, well, do you know what? If it ain't broken, why fix it?
Well, yeah, I'd have to agree, that using the generator every day is great for us to make sure that everything's connected properly, we haven't got a bad cable, things of that nature. But doing an actual calibrated measurement every day would take time, and of course a lot of us are third-party labs and time is exactly equal to money. So you want to make sure you're doing it correct and everything's set up correctly, but you don't have the time to do all of those types of measurements. So what do? You try to come up with ways to make sure it's correct and still be quick about it. So for example, when you do a conducted emission measurement, the table has to be 40 centimeters away from the vertical reference plane. So I had a stick that we use that we cut to 40 centimeters. I put it in there, pull the table up to it. Okay, now I'm at the same place every time. Well, one of my auditors came in and wanted to know where the calibration data was for that stick. Yeah, it's just kind of, where can you make sense of these things?
This traceable, huh?
Yeah, this traceable stick. And did you use a calibrated measuring device to measure the 40 cent? So it's a difficult thing to mandate and to get taken care of. But that's why when we use our comb generator, we implicitly say it's just for us to do a basic system check, not a calibrated check, because then we have all that traceability that has to go with it.
And
I just want to jump in. Sorry guys, 5 minutes left on this topic.
On the 5 minutes left on this topic, so do you same experience as Bruce, that 40 gigahertz is very sensitive to position and so forth?
Oh, absolutely. Anything over 18 gigahertz, your position is so very critical, and you do the best you can. We've got a spot on the table that's painted for our generator for that frequency, but you still could be off a little bit.
I hope your paint spot is calibrated. So, where are we, guys? We're about to break into questions from the audience. Is there any other inputs? If it's, as moderator, if I sum up where I think we are, there's some exasperation in fixing the oats issue. It does seem to be a random reference, and no industry needs that. However, I think everyone in the panel will stand behind it being the golden reference for EMC from 100 megahertz up, but not down at 30 megahertz. Something needs fixing somewhere, and maybe these things will be allowed to wither on the vine, and we will never hear or see of them again. Other than, was it you, Bruce, who said you've got all this equipment already out there that has been calibrated, and if you do the same tests in a different environment and get very different results, is it right or is it wrong? That's the thing there. And kind of related with this golden emitter, I do wonder, when you make an emissions measurement and you look at it and make sure it lies below the limit lines, how true is that? I just wonder if there isn't some way we could use a spot frequency and an amplifier and an antenna and just see that, if only for logarithmically spaced, and if we can tighten up how many times you have to do it and with what. But say just on 10 spot frequencies of known field strength, what is our test system actually reading, and is it good? Let's see. Now, one last bit before we go into questions. I don't know, but suspect that when the powers that be do come up with limit lines, that they try and factor in some of these unknowns. Anyone any experience on that? Am I right in that guess, or am I completely wrong? Deathly silence.
This is Patrick. I would think that there, bringing the idea of amplifiers and antennas. Now you're introducing, what amplifier and how many dB and how much power and what type of antenna and how many dB and what configuration is this antenna, and using that as some type of check, I think introduces more variables and more confusion than doing what's already being done, just using a cone generator and verifying that it's the same every day. I don't know if we can come up with a universal standard for verifying either OATs or alternative test sites like chambers that can be used everywhere, that's going to give the same results. I think there are just way too many variables in this.
Yeah, so you see a danger in going for our own, even if we used a calibrated coupler and calibrated power meter and used a single spot frequency, and we knew the cable loss and we knew antenna, radiation pattern, and all these great things, that would probably cause more problems than it solves, you think?
Absolutely. If each one of those things is plus or minus 2 dB in our world of plus or minus 2 dB tolerances, we're adding a lot of plus or minus 2 dBs together, even doing the proper math. But still, I think it's adding more variables than we really want to add.
Is there any truth in my guess that the powers that be that set limit lines for emissions actually factor in some of these things? Some of the things, like, for instance, the chamber itself, not unlike the OATs, uses NSA as to prove its performance, plus or minus 4 dB.
Well, as a scientist, as a physicist, I would love to ask the rest of the panel, who in the world came up with these limit lines, and how were they chosen to begin with?
Well, my guess is they sit down, a little like the C63-4 guys, and they say, okay, what are our uncertainties? How can we cover this? One of the things they do, I believe, is you have an emitter with the limit lines, and you have susceptibility with limit lines, and they make sure there's a big gap between the two, when they decide on these limit lines. And given the unknowns, they probably factor those in too, but I don't know, just guessing that. Does anyone heard of such a thing, that where basically they try to factor in, I'm not just going to say uncertainties, but almost unknowns?
So in essence, we're saying that this was done by committee.
Done by committee, by educated guess.
Yeah.
It's hard to say exactly because yes, there is some synergy between immunity levels and emissions levels. You want to make sure that you're not interfering, and I almost would like to speculate that they pretty much guessed at first, and now that they're using these limits and find very little instances of interference, that there's no reason to change them.
Yeah. So it's almost time to sign off and maybe take a question or two from the audience. But I have this nagging doubt that I think the whole reason that we have this public forum and the reason it's quite popular amongst the audience is that there doesn't seem to be anyone actually chasing this professionally. What I mean is the industry doesn't hire the best and greatest guys at $200,000 each, these great engineers, to get to the bottom of that, because they're not set up to do that. They're almost like a volunteer force. It's where you get people who will spend, I don't know, 1 or 2 man days a year, and their company will give it up as free to go and sit down on a committee or to investigate this, investigate that. And I think some of the issues we're seeing is basically because they're so reliant on the goodwill of amateurs and of companies giving up resource to try and help the industry generally. But that's hardly the same thing as having professional guys dedicated to look into some of these issues. What are your thoughts on that, panel? You agree, or am I wrong?
I would have to agree. I mean, personally, I've heard of labs and people working to get their site attenuation in check, but I haven't heard of very many that are interested in making sure they compare to another laboratory, or they have the interlaboratory comparison down pat. So it just doesn't seem, as stated before, that there's that much emphasis in the industry to make sure that they're all the same.
And maybe what I just outlined is the reason. In whose interest is it to push really hard? And see, you've got the various accreditation bodies which compete. You've got the private laboratories that compete. In whose interest is it to really, really push this hard and come up with some fixes for it? That's the real question. And so, Belinda, are there any questions?
Thanks, Tom. We did get a few. Let me take a look. We are, let's see. Okay. Hold on. Okay. How do we correlate the results of different test methods for radiated and conducted susceptibility? Like temp cell, strip line, radiated, BCI, etc. What's the preferred test method?
Ooh, I don't know the answer, but I think I know some of the background. When I first came into the industry, it would be about 1990 something, GTEMs were just coming into their own, and the big thing was getting them to be equivalent to a NOTES test site, so that you could use them for actual, what's the word again? Not pre-compliance, truly compliant. You could use a GTEM cell, as long as it was small enough and didn't load the GTEM too much. You could say, hey, this is everybody's good as a NOTES. So, unless I'm mistaken, everything leads up to the golden reference that we know as OATS. Am I right, guys?
That's correct.
Okay, so I think the question was, Belinda, how do you correlate between the different test methods? Did I just answer it in one?
Yes, I believe so. Here's another question. How do we verify a pre-compliance chamber which doesn't meet the minimum 3-meter requirement, antenna to probe, for field uniformity?
Ooh, well, that's let me pop in there quickly. It might be of interest to this particular audience member to listen in to the talk I'm giving tomorrow, because I'm giving a talk on actually creating a test field and how you transpose the calibration matrix onto a polar plot, and you try and work out, well, you not work out, but you can actually both quantitatively and qualitatively see how the calibration matrix is going to be illuminated by the test field. So you might want to listen into that anyway. But how do you for the non-compliant chamber, I guess we need to know what we mean by non-compliant. Does that mean that only one wall is absorbent lines and the rest is fully reflecting? But what was the question again, Belinda, because I forget?
It said, how do we verify a pre-compliance chamber which doesn't meet the minimum 3-meter requirement for field uniformity?
Okay. Anyone else want to kick in rather than...
You know, I guess what I would say there is, first you'd have to do a series of measurements, maybe on several different items in the chamber, and then take it to a place that is compliant and see how those two measurements differ. You probably want to do that also with a comb generator and units of various size, because especially in a non-compliant chamber, it's going to end the size, a small chamber, the size of the product you're testing is going to be pretty important. The bigger the product, the more it's going to interact with the chamber, and the more variables you're going to end up having. That's a tough question, but that may be the best you're going to be able to do.
Yeah, trying to read into the question. I guess what happens, you got the 16 points that you put your field probe at, and you measure them all, and they all have to be minus 0 dB and plus 6 dB. I'm assuming commercial, and what do you do if it doesn't? And that's the question there. And I would look at.
That's for immunity.
Yeah, I'm assuming it is immunity. Yes. Yes, and so
okay.
Yeah, so I'm guessing not all 16 are compliant. You're allowed to throw 4 of them away. So even if we've got to get 12 right, and if you can't get those 12 right, what do you do? Well, I'd be very tempted to borrow or buy some absorber and to start placing an absorber in place of the fully reflective 4. That's the first thing I'd try and do. The second thing I'd try and do, because it's very sensitive to it, is look at the area under the antenna. Look at both ferrite and a pyramidal absorber around and under the antenna. You'll probably find that helps. But you would really, I think, for anyone on the panel to answer, you would have to have a photograph and a description of the test setup.
Correct, and if it is indeed the uniform field for like 61004-3, it does not have to be at 3 meters, but it cannot be any closer than 1 meter. So if you're short on that 3 meter distance, you can still prove that you have the field uniformity at those 12 points. You can still use that chamber.
So we're having to guess, because obviously we don't have any direct interaction with the questioner, but basically he's not getting his 12 points. And so what do you do? What do you do? Well, I'd look at the wise placement of absorber.
Yeah, more absorber.
Yeah, and that's probably right. And so, Belinda, I think we've kind of fizzled out at that point. Any more questions?
We have a few, but we've run out of time, so I will send all the questions along to the panel to be answered later on if they'd like. We've received quite a few questions on the topic. People can visit emclive2015.com or interferencetechnology.com. And you can also email us at info@interferencetechnology.com with specific needs, and we can direct you accordingly. We'll try to address these questions in the future. Please join us tomorrow for Tom's webinar this week on choosing the right antenna for today's testing requirements. That'll be tomorrow, Wednesday, April 29th at 4 p.m. Eastern Time. Panel members will be expanding on their thoughts on our blog, emc-zone.com. Please join them there as the discussion continues. Thanks for attending.
Thank you.